Oh, yeah, let's take, after all that semi-stressful talk for some of us, me included, let's take a moment to bring it home. Alrighty, so laptops, just stop doing. Would you stop doing stuff, please, for just a couple of minutes? Just take a minute and just see if you can just let go of everything. Stop trying. It's all you do all day long. You get up and you try. Just let your shoulders fall down and back. Not forcing them, just letting the weight of your elbows, your arms, bring them down. Notice if there's any tension in your jaw. Soften your eyes. If you're holding any tension in your temple area or just around your eyes, can you let go about 10% of that tension? Every time you start thinking about what's going to happen or what has happened today, just let go of it like we're holding on to something with your hand. Just release it. When it comes back, just let go again. When I say let go, I just mean come back to the sensations you're feeling right now. That could just be as simple as your shoulders. Just checking to see how relaxed they are. Check it back in with your shoulders, and your jaw and your eyes, just over and over again. Give your fingers a little wiggle, your toes a little wiggle. When you're ready, if you're ready, open your eyes. Sooner or later, you gotta come to calc class, but take your time getting there. I needed that too. Your story stressed me out, friends. All right, am I rolling, Josh?
Yes, you are.
Thank you, sir. Clearly I have the memory of a gnat. All right, I wanted to, hopefully you got the email, like work on some web work today, get that maybe closer to being done. And I wanted to start off with a couple examples working together of Euler's method. And I want get those, if you have those handouts that I made with the, and if you need another one, I've got some extras. If you are, like, may have lost that or just forgot it or something, it's all good. I want to make sense of this because it's got a different notation on it than I've been using, and it might be, not clear. Awesome. So let's actually take a look at one of these tables, but let's get a problem up first. So we want to look at this problem. We're going to do two things to it. So consider the problem. X dot equals x squared over t with x at negative 1 equals 1. So we're going to do two things on this. First part is use Euler's method with delta t equals, I think we'll just go with 0.5. That's going to be pretty lousy, but it's okay. We're actually not trying to like launch a rocket here with our computation, so everything's going to be a-okay. To estimate x at 1. So let's think about what that means. There's a couple things hidden in this problem that I haven't quite said this way before. So let's draw out a picture. It can help sometimes. And we've got x at negative 1. So here's my t-axis, here's my x-axis, is equal to 1. So it's negative 1 and 1. So this is my initial condition. And we have a step size of 1/2. So we're going to find the next point here at negative 0.5, and then at 0, and then at 1/2, and then at 1. So we're going to need 1, 2, 3, 4 iterations of Euler's method to get what this says. So i.e. do 4 iterations of Euler's method. So let's use the chart that we've got here. We've got this top chart that looks like this. It's got an I, and then a t sub I, and then an x sub I, and then dx dt, and then delta x. And I think once we explain this, so I'll be given that like take-home thing on Wednesday, and we'll spend the whole day in class Wednesday and Friday working on it. There will be like an Euler's method problem on there, and I'll make the table like this so that you have something to model it off of. So we need 4 iterations. This one when I equals 0, this is the initial state. So we can go through and actually initialize this table. T sub I is this right here. This is T sub 0. So T sub 0 is my initial time. And that is -1 second. Don't worry about thinking about what that might mean. It's just like, what happened just a second before now, I guess, roughly. My initial x value is the output, so this is x naught, that's 1. And then these are things we're going to compute. So dx dt is going to be computed from the right-hand side of your equation. So you're going to use the equation to find the current dx dt at each step. And you're going to use these values right here, this t whatever and x whatever. I'm going to plug those into that formula, which is this, to find those. So here, dx dt, and I'm using, I'll write, that just means this, is computed by the x coordinate squared over the t coordinate. So this right here is my f of tx. this formula right here. And then this delta x is going to be the change in x. So the delta x is going to equal the current slope times the delta t times the time step. So this is going to be the current, and I'm going to write this a bunch of ways so that it makes sense. The current dx dt times the delta t that we're given. This will never change. That delta t is your pendulum on your clock. Keeps you moving along. It's very regular. It's not going to alter throughout the process. So let's go forth and crank this out. So we need, check this out. Let me give you a second, make sure you understand what it is we're trying to do and what we got. And let me let you get caught up with writing stuff down. Any questions on like the setup or what's up? Great. So dx dt, I'm always going to use this formula right here. So let's write it out for the first couple times when we write it. Right now when t is equal to -1 and x is equal to 1, this is just going to be, this is x squared over t, so it's equal to 1 squared over -1. So it's just -1. Right, it's super tiny. Sorry, it's uber tiny, as the Germans would say partly. They wouldn't say the other part. So this is just -1 in here. So my initial slope, like when I'm right here, this thing's saying you're going to head down at an angle, and we just want to figure out how far to go down at that angle. And that's where the next part comes in. This is the change in x, because we know what change horizontally is going to be. It's just a half a unit every time. So this is going to be -1 times my delta x, in other words, -0.5. So I want to put a general statement here in this one. The t sub I, this will increment by delta t each row. This will increment by delta x each row, by the previous delta x each row. So for this update here, I'm going to use that -1/2 to update this x. And what do I mean by update? We're going to take previous equals previous x value plus delta x. And this will make more sense as I start to go through it. Hopefully it's not too far out. So the I part here, this is just like, we're just gonna, oh, here's the first, here's the second. So there's nothing fancy going on here. It's just like the row number, essentially. It doesn't play a role in any of the computations. It just tells us what step we're on. So for our first step, what's the next t sub I? Goes -1, not 0, -1/2, right? Because I'm adding a half to it each time. So t sub I, delta t is a half. And so I take my current t, which is -1 plus a half. Let me put this here, Olivia, so plus a half. Each time, this is just gonna, I'm gonna add a half to it. Does that make sense?
Yeah.
Okay. All right, so my x sub I, my x sub 1 is going to be 1, the old x value, plus the delta x from the last row, so -1/2, and that's going to equal a half. So it's this plus that That's the new state. This makes sense. If the slope here is -1, and I moved over half a unit, I should go down half a unit. So my next point here is -0.5, +0.5. That's my next point. I could connect those with a line if I even wanted to. Pretty chunky solution, but you know, it's just an estimate. And then dx, now this gets based off these new values, so check this out. This dx dt depends on these. So it's going to equal, so it's, again, it's x squared over t, the current x squared over t. So it's 1/2 squared over -1/2. And then that looks to me like just -0.5, I think. Right, because that's, yeah, I mean, one of these cancels, that's just -0.5. Sorry, that's really shitty, the way that's written, it's so illegible. So it's -0.5. Let me know if that looks okay. Let me stop. Make sure you're with me. And if you're not with me, let me know. Now is the time to talk. I did like leg day yesterday with my wife and I could barely walk. Like, so stiff. Aren't you proud of me, Kelby?
So proud.
Thanks. Knew you would. All right. So any questions about how I got -0.5 there? All right. Then delta x, the delta x is now dx dt. So this is dx dt times delta t, and so that's going to equal -0.5 times the delta t, which is 1/2, and that is -1/4, so -0.25. All right, so that means I only went down 1/4 of a unit in this next step. And so that lands me right here, because that whole thing's 1/2, so half of that is, there's the 1/4. So that's 0.25 right there. I think having that little picture helps. I think it helps visualize what we are doing here, because otherwise it's just a table full of numbers and it can look really not meaningful. Could you do the next row, please, and then let's check up. So row 2, what's going to happen there? value goes up by another half, takes me to 0. The x, I take the old x and the delta x and combine them. I add these together to get my updated x value, right? So it's this plus that gives me that. And that's kind of what I drew here as well. So we're at 0, a quarter. Any questions on those? All right, so then I update the rest. Now the rest of this is based on this, right? What's in this happening in this row. Notice that this row right here depends on the previous row. So let's write that out. Maybe this row depends on the previous row. This is its own thing. This doesn't know about anybody except itself. It just clicking. This row, these two columns depend on the current row. So that means I'm going to use the formula for dx dt that the equation's all about. So dx dt is equal to x squared over t. So that's 0.25 squared over, oh shit. Well. It all looked so good at home. You see my problem? Kind of just divided by 0. Well, I didn't yet, but it looks like I did. Let's just pretend for a second. Let's just pretend. I'm just gonna carry it along. So this is some number. And then this number here would be, because we can't really go on. Damn it. So this would be 0. I should have picked a different time step. What would have been good is to pick a time step that didn't include t equals 0. That would have been a weird ass time step, but so this would be that value. Damn it. So 0.25 squared over 0. It's this times delta t. And then whatever that is garbage. Right curse words there. Do you understand how to fill the row? Okay, so like on anything I give you, I'll make sure to work it through completely ahead of time. Okay, that's part 1. It's not the problem's fault, it's my fault. I'm flipping myself off. All right, so, well, we won't be doing, how many more iterations would we need if this all worked out to get to the estimate I'm asking for? 2 more, right? 2 more, because to get to x to 1, I'd have to go 1, 2 more iterates to figure out what we were there. Son of a gun. All right, well, that's part 1. You're welcome. Notice no one seems very thankful, nor should they be. How embarrassing. Well, part 2. Solve by separation of variables. This will work out.
Can I get another sheet?
Sure. Sir. You're welcome. And there's one on the back too, but yeah, you can have as many as you want. That's actually my last one, so you can't have as many as you want, but I'll make you more. At least right now you can. Solve by separation of variables. And remember that involves writing this as a fraction, getting the x stuff with the dx, the t stuff with the dt, using some simple algebra, integrating each side, adding a plus c, incorporating the initial condition to find the plus c. that should be your first manipulation. Make sure we're on the right path. You will definitely need the absolute values on there because you can't take the log of a negative, so make sure, in general with these diffie Qs, when you integrate a log form, slap on the absolute values for ultimate safety. Should all have something about like that. Walk through it. It's best written as a power, this X thing. So I can use the power rule, just power ruled it. It's kind of Calc 1 stuff going on here. And then that, just integrate, goes to a log form, add plus C to the independent variable side. So always put that plus C on the independent variable part, the of part in here. Any questions on that? No? All right, then I multiply it through by a negative to get rid of the negative. So I put it here, multiply both sides by negative. I absorbed the negative into the C. So you might be like, why didn't he write this? And that would be okay. But part of the fun of these is that C eats everything. That's a constant. So you could leave it like that. There's nothing wrong with this answer. Nothing wrong with that. But it's more fun to write that. Because eventually I'm going to solve for the C. It doesn't matter if there's a minus or a plus here, or the 3 or pi in front. It'll all come out in the wash. So then this is 1 over x right here. So I took the reciprocal of each side to get this. And this is probably the best form right here. So this is my general solution. And now we see why t equals 0 is kind of a barfy value, right? T equals 0 doesn't, log isn't defined for 0. So that sounds right. So now I'm going to find C using the initial condition that says that x equals 1 when t equals negative 1. So I'm going to plug in 1 for x, negative 1 for t, and you see why I need that absolute value, or I hope you do. So plug these in, and you get 1 equals 1 over negative natural log of 1, or negative absolute value of negative 1, plus c. What's log of 1? 0. Yeah. So this is just 1 equals 1 over c. So c equals 1. And then I rewrite my final solution. I plug the c back into that form up there. So plug this specific c into the general solution, and here I get my specific solution. X equals 1 over negative natural log of t, absolute value, plus c, plus 1. Hello. That's it. That's what we want. That's the goal. All right, cool. It's not bad, right? It's like the algebra is probably the most painful part. And then the rest will probably be straightforward calc integration. Let's do one more. I would like you to do, I think this one's gonna be okay. It should be. I like graph these solutions out on the little app that I posted on World Class, and everything looked pretty kosher. So this last one is a y and x one, because I wanted us to practice that. So solve by separation. This one is not, oh, no, silly. Estimate, sorry, this is not separable. Good Lord. Estimate the solution when x equals 2 for y prime equals x squared minus y squared with y at 0 equals 1 using Euler's method. So notice the table. Let's talk about the change up here. This is the second tables on the bottom. Oh, sorry, Cassie. Yeah.
What increment are we going about?
Oh, hey, there's a great question. There's a person who knows Euler's method. Let's using delta x equals a half. Let's just stick with that nice half because it's easy to work with. And then how many iterations will I need? So we're at y at 0 is 1. So here's my initial condition. Here's y and x. So I wanted to do this because it's very confusing sometimes to have that x and t and then the x and y. And here the x is the independent variable. So this is my initial condition. And we want to get to 2. So how many iterations will it take? With delta x equals a half.
4.
4, perfect, nice loop, yep. Because I want to get to x equals 2. So here's the first iteration gets me here. Second iteration gets me here. Third iteration gets me here. And then next iteration gets me here. And let's just do a couple, make sure we got it, because it might end up kind of nasty, like without a calculator. So let's just get that table out, and here, the same game is going to apply. It's just some slightly different notation. We've got I, we've got x of I, so this is the thing that's going to increment by delta x each step. This next one is y sub I. This is my current y sub I. This depends on the previous row. So this gets updated from previous row values. It's going to be initialized by the initial condition, but it will be updated for previous row values with the new y equals the old y plus the delta y. Previous row. When I say old, I mean previous row. Put old there, whatever. And then we've got dy dx. This is my current slope. So this depends on current values. And then this is going to be delta y. These both depend on current values. This row, this column here is going to be dy dx times delta x. That's what goes in this row right here. So you take this times delta x and you get that value. So let's get it initialized. Initial state is when I equals 0, x is 0, and y is 1. What is my slope there? What is my slope at this point? -1. How'd you get that? That's beautiful.
Plugging x and y into the equation.
Exactly, so 0 squared minus 1 squared. So this is 0 squared minus 1 squared, because that's these values, so -1. And then delta y is just going to be the delta x, which is a half, times that. So this is -1 times 0.5 is -0.5. All right, next row. What's my next x value? Tick tock, tick tock. 0.5, just kicking along. This is the thing where computation is going to take place. I'm going to take this plus this. It's the old y value plus the delta y, so this is equal to 1 minus 0.5. It's just 0.5. A lot of halves today. That'll change in the next row right away. What is my slope here?
Y squared over x.
We got a different equation here, Lou. So it's x squared minus y squared.
Oh, yeah.
0 here, yeah, does you see that? Because they're the same, but yeah, does that make sense, Lou? You get that? So 0.5 squared minus 0.5 squared equals 0. Awesome. Delta y is this times delta x, so it's 0 times 0.5, it's 0. Let's draw what's happening here. So we moved from here, and our next point was a half. So we traveled to there. Now it's telling me my slope is horizontal at this point. So we plan to just move straight across. But let's do this all very carefully. So when I equals 2, what's the next x value? 2. 1. Yep. Just keep adding half, right? Yeah. Thanks. What is my y value going to be?
0.
1/2. It's the old y value plus the delta y, right? So remember here, this is old y plus old delta y. So it's that plus that, and that gives me 0.5. Now things will get fun. What's my current slope?
0.75?
Yeah, 0.75. It's because it's the x squared, which is 1, minus the y squared, which is a half, and squaring that you get a quarter. So this is 1 squared minus 0.5 squared, and that's 0.75. What's delta y?
0.375.
Oh, there is a lady who knows how to take half of 3/4, exactly. So that is 0.375. Does that make sense to everybody? It's half that. Beautiful. Can you do the next row, please? You might want to have a little calculator or something handy. I don't multiply 0.375 squared out by it, so you know what? Get a calculator out or whatever. You got your laptop with you today for web work, or whatever that's worth. This is taking 45 minutes. Lord. All right. I'll pay the price. Be the math piper. Oh my God, I have not done this in so long.
0.765625.
That's what I was gonna say. What was I gonna say?
0.765625.
Thank you.
You're welcome.
Yep. That sounds right, sure. Did I get 1.5 squared is 2.25?
Yes.
Okay, thank you. And then, what would I probably say this simplifies to?
1.48.
Thank you. Yes. That's my slope. And so my next delta y is just half of that, so 0.74.
Yep.
Cool. That's enough. Then, so yeah, so it actually, let me see. Yeah, so this is the last point that I know I'd have to like do this whole thing. I'd have to take 0.74, add it to this y to get my next value, but you can see it goes up by about 3/4. So we could estimate, if this is 2, it's like gets to about half or something like that. 0.875 plus 0.74. So we get a sense. We get a sense of the solution. And that's enough. You all seem sensed out, so good job. Not being sensed out, but good job working on this. Doing it. Let's take the last half hour. Try to get through that web work. I didn't see a lot of folks get close to done yet, so I know we got some work to do.
Can you do one on the board from web work?
Totally. I would love to.
It's, okay. Yeah. Actually, wait.
I have one.
Okay.
Yeah, you can do it.
All right. What you got, Josh?
It's number 10.
Okay. Number 10. Ooh, you're far.
Well.
Well, you're doing number 10 first, or maybe no?
Well, I skipped a lot.
Okay. Okay.
dz over dt
Okay.
equals 4t e to the z.
Oh, I remember this one. Yeah,
Yeah.
yeah. Was there an initial condition or not?
The origin. So 0,
0, 0. Okay. So z at 0, 0. All right. Cool. So separate. These are all separate. We know the game.
Yep.
So at least we got that going. So I'm going to bring that e to the z under. Bring the dt over. Does that look like a first decent move? I mean,
Yeah.
okay, so then to integrate, I would rewrite this left side as e to the negative z dz, which might be what, I could see that causing some problems. It'd be like, is that a log? What is that? It's just an e to the negative z. And then I would use, this is a power rule, right? So that's good old power rule. And I would use this rule here to do the left side. Comes in handy, right? Nice to have that rule around. And then I would add my plus c to the right. Let me give you a second to do that, and then we'll come back and check it, because I don't want to take all the fun away.
The negative would come out front in that case.
Yes, ma'am. What's the left side gonna be?
Negative e to the negative z,
Correct. And then what's the right side?
2t squared.
Beautiful. Plus c. So I want to get, ideally I want to get the z isolated. I want to have c of t equals something. This is actually a solution. This is called an implicit solution. And it correctly relates z and t together. But I would like to solve for z, because I just like doing that. I like that explicit form. So I would first multiply both sides by -1. And I would absorb that -1 into the c. And then I would use this rule. E to the something equals blah, means blah, something equals the log of blah.
Wouldn't you change the sign on C?
You could. It would be okay to put a minus there. But I would encourage you to like absorb constants in. So like if I multiplied both sides by 5, I would just still write it as C instead of 5C.
Oh, you wouldn't, okay.
Yeah.
You just leave it alone.
Yeah, exactly. Yeah, you just think of it as absorbing constants.
Okay.
And it just makes the computation simple in the end. And if you queue with me in spring, we're gonna be doing this. This is our lifestyle. So, can you now finish it? Your next step is going to be this. You'll have a negative z equals something. You'll still have to multiply through by a negative, but what is that something going to be?
Wouldn't it not work?
So I'm starting to wonder.
Because you get ln 0 and that's unsigned.
Yeah, you're right. Yeah. No, it does. Nope, we're okay. Watch.
Because the C.
Because the C will end up being 1, I think.
0?
Can you elaborate?
Yes, I can, and I shall. What should I put here first?
ln and then everything else.
Beautiful. Agreed, and then I would multiply through by negative. And now, I see what you're saying, Kelby, because I was almost convinced for a second there. But let's plug in the stuff. So z equals 0, and then this is 0. But natural log of what is 0, Kelby? It's not 0.
Wait, what?
C. So yeah, so I got natural log of c equals 0. What is c? 1. Does that make sense?
Yeah.
Yeah, no, you got me too with that. I almost believed that too. And then I thought, I didn't make this problem up, it can't be that fouled. If I had, like earlier today, then I believe it could be bad. But then plug this back in to the second line. And we get that beauty right there. Does that make sense, Josh?
It does.
Awesome. Okay,
So
cool.
on 8,
Yes.
it only gives you the initial condition that x is greater than 0.
Oh, let me take a look.
Have you,
Oh, okay, so that's actually not an initial condition. I'll show you what, let's talk about it.
okay,
Yeah, so it's dy dx equals 4y over x?
yes.
Okay. And I'll just make that a 3 for the hell of it. And then they're telling us that x is greater than 0. So just a little note, this is not an initial condition. What it is we're gonna end up with a natural log in here, and it's gonna be like a natural log of an absolute value of x. And so it's going to allow us to,
Then what would you put in, though, for your x and your y?
wait, say that again?
Cause it's well, wait,
You cool?
yep, I'm
Woohoo!
good. Figured it out.
So yeah, so this is just so you can remove the absolute value in the log. Or wherever. Got it. Anybody else have stuff they want to talk about on that? Josh? Yeah. Oh, yeah, Olivia, yeah.
I just want to know.
Okay, sure. Take a look.
I would go do it.
Yep, beautiful. Yeah, love that.
And then you just,
So, yeah, this is all great. Yeah, that's awesome.
so then you just square both sides. And you have to put plus or minus, right?
Correct.
But
Yeah,
how-
unless they've told us something weird, yeah.
So then I can't.
Oh, but look, no, you don't, look at what they're asking for.
So-
Woohoo!
so I'm done.
Just type that, yeah, try it, that's cool.
Oh, good.
What problem is that?
That's number 6.
Hey, friends, on number 6, keep an eye out. On number 6, they're asking you to find y squared. So you don't have to take the square root, because we almost did that over there. So your answer is solve for y squared, don't take the square root. What's going on, Fernanda? Yeah, I'm coming over. Josh, do you have another one too?
Yeah.
All right, we'll talk. Yes, ma'am.
Okay, so let's, will you, oh, okay. Okay, so let's go through, so. That's great. Yeah, I love that, and then you put in, your initial condition was,
0, 2.
oh, 0, 2.
Yeah.
Oh, here, can you erase that absolute value for me? Because that should be on the other side of the C, so the, yes, yes. Oh, and you had that here, so, okay. Yeah, you still have that here, so that's okay. So 0 equals, C equals 1. Yeah, and I think it just wants the absolute values, so replace those with a shift 6, or shift colon, probably, or shift backslash, there it is. Straight line. Take a look. Yeah. Okay, so. Just gonna double check everything. Okay. Solid. And there, we want ours to, you want yours to go through the origin, so this should be negative. Oh, it is. Oh, I see, okay. Oh, it is, okay, duh, never mind. Yeah, I thought there was a 2 or something, it's usually, no. negative 4t squared.
Oh,
So the negative,
yeah, that's right.
Also inside, there you go. I think it's gonna be green, so you hit that, there you go,
Yeah.
awesome.
Thanks.
You're welcome. Yes, sir.
I'm trying to clarify how to do these three problems.
Okay. Oh, okay, so let me talk about that one up in front of everybody.
Oh, all right.
Number 5. Problem number 5. I'm glad you asked, Josh, thank you. Because I wanted somebody to ask about that, because I thought it might be a little confusing how to talk about it. So problem number 5, they give you a direction field. It doesn't look like this. They give you a direction field and then optional functions that it could be. So do they give you just one direction
They give you
field or
4.
multiple? 4.
Yeah.
So you have to pair them up,
Yeah.
right? What could be the solution? So you get these 4 different direction fields, and then you have these 4 different functions. What I would do is go to Desmos and plot these functions and look to see which direction field they are consistent with. Like which one would they be a flow in?
Yeah.
So that's how I would do that one, Josh. Does that make sense?
Yeah.
That's about the only way I know how to do that.
Well, they give you instructions on how to do it.
What do they say?
It's kind of long. It says set y equal to 0, then look how the derivatives behave.
No.
Then do the same for the y-axis by setting x equal to 0.
No, that's bullshit. Just go plot them on Desmos and see which one works in the thing. That's what I went. When I looked at that problem and assigned it, I was like, that's what I would do. Let's see how well that works. Maybe it's not that easy.
Wait, what do you put into Desmos?
Let's take a look. All right, let's see here. So, oh my God,
Yeah.
good Lord.
I know it's y prime, but
Oh wait, shit, no. Go to the slope field plotter. Sorry, so number 5, yeah, there's another one. So this is actually a different problem where you're gonna need to do this. On number 5, go to the direction field apps that I put up in World Class and just plot the D fields there. That's the way to do that one, Josh, yeah. Yes?
I don't know how to do this. I don't know how to start this.
Oh, okay, so let me talk about how to do that. Let's see, is that, they gave us the Rx, so find the values of R, okay, got it. Which problem is that, Kelby?
Number 2.
Thank you. So problem number 2. Actually not that bad, so let me show you how to do it. Find all values of R so that, do they have Y or X? They use Y, right?
Y equals K e to the Rx.
Thank you. Such that that is a solution to, and then we got like y double prime minus, I'll just do 81 here, equals 0. So that's a double prime. So what you need to do, it's kind of like you're checking the solution. So you need to find the second derivative of y in that general form. So for example, yours will be like this too, so this will make it easy. So y prime is what? What's that y prime? Yep, Rx, yep, thank you. And then what's y double prime? Beautiful. Just like that. And so now, Kelby, I'm gonna plug those into the equation. So I'm gonna plug into the equation, and so that's gonna say r squared k e to the rx minus 81 k e to the rx must equal 0. So let's talk about some things. You can factor some stuff out here. So r squared minus 81 times k e to the rx equals 0. So this is going to equal 0. So e never equals 0, right? You look at a graph of e, it doesn't matter what the exponent is, it's never 0. So this can't be 0. That k could be 0, but I think they're asking for the values of r that would make this true for all k. So that means this piece has to be 0. So in other words, when r squared minus 81 equals 0, I'm good to go. So plus or minus 9. Your problem will be very similar.
Wow.
That's why they got that nice perfect square there too. You got 36, right? Yeah.
Thanks.
You're so welcome. This will all be on the video if you want to check it out later. You might want to, or take a picture or something before you go. Josh, yes.
Last question I have is for number 1. It's kind of the same thing.
Yeah. So it's just find the second derivative
That's all it is.
with respect to t. Yeah, and then add the two together. So add this plus its second derivative and simplify. Yeah, and I think you'll like the answer. Yes.
I'm kind of confused on like this one. Like the independent variables. Would the independent variable be like always this one?
It's always the top one.
And then we would add c to the one on the other side.
Correct. Yes, ma'am.
So for this one, am I doing this right?
Yep. And just a little tip, you could left that 3 over there, and it makes life a little bit, it doesn't matter. This is all beautiful. We'll talk about that stuff in the spring. This is all great. I like it. Yeah, you're doing great.
So then,
But you're still gonna need to get that 1/3. You're still gonna need to multiply by 3. So I guess that was why I was saying, like, if you just brought the y under and just moved the dt up, you'd have 3 dt here. And you're gonna need it anyway. All of a sudden, you're gonna need to multiply through by 3. Does that make sense?
yeah.
And then use that, that equivalence. Yeah. Yep. If your nail color
Did
is,
you put a comma?
yeah.
That is so cool.
Really?
That green, I love that.
Thank you.
Yeah, I like green.
Mhm.
Oh, you good? You got it all? Yes.
So,
Okay, let's take a little look. So beautiful. That looks good. Yep, I like that.
You lost your negative. Oh no, then it came back, so that's good. Okay, it disappeared and then it came back. Oh, no. No, that was okay, not that one, the one in the exponent. That was all I was saying. So it was supposed to be a negative, but then it popped back into existence down here, so that was good. That's good, leave it there, that's good. So you undid this, that's beautiful. And then,
and I'm just like stuck.
so now, you just want to solve for z, so divide by 7. Z equals negative 1/7, natural log of that stuff. You're so right there.
-1/7.
And that's your z, yeah, you see?
Yeah.
Yeah, you're right there,
Also,
yeah.
also, I was doing, this,
Yeah.
and I
Okay.
got to here.
Okay,
And the y intercepted.
so here's your word for this.
This
I don't think this is the right problem.
This isn't the right problem. This isn't the right problem.
There it is.
Oh, there it is.
Okay, cool. So little tip on this one, I would leave that 42 over here. And I'll show you what, because this is actually not the right antiderivative. Because what would the derivative of this be? Let's think about it. Because the derivative of this should be the thing up inside. Yeah. It would be 42 over 42y, because the chain rule. Yeah, so it would just be 1 over y.
Yeah.
So what I would recommend, this thing here, just put it over here. So multiply both sides by 40, so you have 42 x to the 5th. And then, wow. pencil seen some days, so let's keep out of there. This will just make life so much simpler.
Oh, yeah.
You see what I'm saying? So like put a 42 there in this next one, so right in front of that. Yeah, on the X side, yeah. Yeah, and divided by, wait, so you up here, so you wanna divide by 7, so it's 42 over 6. Cause you increment by 1, right? Which makes it nice, that's why they have that 42 there, cause 42 divides nicely by 7.
Yeah.
Yeah,
So that's
does that make sense?
42 times 6 over
7,
7.
yeah. That'll be 6x to the 6.
Yeah.
Yeah. Then you can do the next move using that equivalency right there. You're gonna go backwards with it. Yeah, right, because you have the square equals log of something.
Oh, yeah.
This is your square, there's the triangle inside there. And you wanna convert it into, you wanna solve for the thing that's inside the log.
Which is,
Yeah, it is. Yeah, but be careful here. So when you do, let's talk about this. And this is something everybody's probably gonna run into at some point. When you have something like this. Whatever. And then when you undo this, it's gonna go to, let's get rid of that too. It's gonna go y equals e to the 5x to the 5th plus c. So that plus c comes up as an exponent. Because this whole thing is the x, right? That's what's in the box.
Yeah.
And so that whole box comes up as the exponent. And then this is a trick. This is 5x squared times e to the c. And then I just call this c again. Do you see? Because this is, I'm using this property here that x to the a, yeah. Okay.
Okay.
Yeah?
Yeah.
Awesome.
And then there's something weird because the y-intercept is 3 when I just,
So that's when x is 0, y is 3.
x is 0, y is 3.
Yeah.
So that's how you come for
Yep.
c.
Now, that's, in that form you have there should be real nice. Should be easy to find it. Kelby, yes.
I think all three of us are.
Okay,
it's not
cool,
7.
okay.
This is how I did it, but it's not that I'm explaining it.
Oh,
This
okay,
is how I did it, but it gives a really bad C.
Because so check out what I did over there. So the plus C, you added the plus C too late. So here, can we all look here? So when you integrated both sides from here to here, I would put the plus C right by that T right away.
Okay.
And then multiply through by 4, and it'd be natural log, natural log of y equals 4t plus 4c. And I could just make that c again. And then when I undo this, when I raise this to e, it becomes plus c in the exponent.
Oh.
And then you can bring it out in front. So this, if you just put that c in front of that e to the 4t, you'll be good to go.
And it's the same. Okay.
Can we come show you what I was talking about? Oh, different question. Yeah, I'll be right there. I'm so glad we're taking off Monday, by the way. We're doing that. That shit's real. That is happening. Yes. Oh, these are equilibrium solutions, right? So they're the ones that just stay constant. So like if you started, yeah.
there's one more.
So it looks like, yeah, you try 2, comma -3 and see what happens.
Yeah, that one was supposed to be quick, so, yeah. Yes. Let's see, what's 4 times 0?
And then what's e to the 0? Oh, right, you got c equals 4, but
Oh, wait,
Yeah, you're combining a couple of different things. Yes,
what's this?
thank you, sir.
there you go. That's it.
Gosh.
Ah, shit.